else is going to come in. All right, cool. Hey, everybody. This is like the nicest conference room I've ever presented in. I've never had like a view. Usually it's like a windowless room. It's awesome. Hey, so my name's Dustin. I'm a member of the Python Packaging Working Group, the Python Packaging Authority. I'm a maintainer, contributor, administrator of PyPI, the Python Package Index. I'm also a developer advocate at Google. So if you use Python and you use Google Cloud products, I would love to talk to you, or if you want to use them someday. So I kind of had a hard time coming up with the title of this talk. And it's not just because naming things are hard, even though naming things is pretty hard. The reason I had a hard time coming up with the title of this talk is because I knew that I wanted to talk about Python packaging, but a lot of people have already given talks about Python packaging. So many, in fact, that every time I came up with a title for this talk, it kind of seemed like someone had already given that talk. So at first I thought, like, what is the core thing you're trying to do with Python packaging? I will call my talk Python Packaging, Getting the Code You Wrote to the People That Want It, Using the Language That You Wrote It in. But this talk has already been done. And that title was pretty long also. So maybe I should do something a little shorter, more clickbaity, something like Python packaging in just 5 easy steps. This has been done. I thought maybe I could one-up this talk. I'll do Python packaging in just 4 easy steps. Guess what? He did that too. Okay, so maybe I should be like kind of encouraging about Python packaging. Python packaging, it's relatively painless now. Just go ahead and use it. No, that's been done. And relatively painless is still like kind of painful, right? So maybe I should try to instill confidence that Python packaging is improving. I'll make my talk Python packaging. We're still trying to make it better. No, that's been done too. All right, maybe I should take a stronger approach. Python packaging, let's just throw it all away and start over from scratch. Nope, that talk's been given. All right, how about, yeah, a lot's been changing. So maybe Python packaging, let me just get you up to speed on everything that's changed since last time. Nope. And then I figured, all right, maybe there's a lot happening in Python packaging, so maybe not everyone cares about everything. So I'll do Python packaging. There's a lot of stuff here. You might not need all of it. No, that was the Python packaging gradient. All right, maybe I should keep it simple. Python packaging in the simplest terms possible for anybody that cares. No, this talk's been given. All right, maybe even simpler. Python packaging so easy a caveman could do it. No. That was a great talk also. He didn't do it all in a caveman voice. So I'm really kind of starting to run out of options here, right? So maybe I should stick to something that's closer to my personal experience. So hello, I'm a PyPI maintainer. At the very least, I should be able to tell you how to use PyPI. Someone already did this too. All right, one last-ditch effort. I'll do Python packaging, but I'll make it Indiana Jones themed, and I'll do it in French. There's no way that this has been done before, right? Yeah, this is real. All right, so it kind of seems like everything that could have been said about Python packaging has already been said. So at this point, I should probably just give you links to all these talks on YouTube. You can go home and watch them, and we'll just like wrap this up right now. Thank you. No. So in the end, I called this talk Inside the Cheeseshop, How Python Packaging Works. And this is a pretty awful title for a number of reasons. So first of all, it's got an obscure reference to something that doesn't make any sense. Why am I talking about cheese? I don't know anything about cheese. The second is Python packaging is an incredibly broad and complex subject. So trying to explain how it works might perhaps be a lost cause. And third, I'm making the assumption that Python packaging actually works. Which has historically been the biggest complaint about the topic. So if you can't read the caption here, it's, my Python environment has become so degraded that my laptop has been declared a Superfund site. But here's the thing. I actually think that Python packaging works pretty great. And we've just gotten used to how good we have it now. So I really, truly want to do some Python packaging archaeology with you all And I want to talk about the evolution of packaging through the years and provide some context for why things are the way they are now. And about how at each step we had a new problem to solve, and then a new solution for that problem, which begat a new problem, on and on. So let's go back in time. Back to a time when Python was brand new, and everything that we're familiar with today did not exist. Back to the beginning where there was just Python. So this is the original, Guido's original release note for the very first version of Python. So pretty much as soon as there was Python, there was something written in Python. So let's pretend that you're the author of this totally awesome library. Nice work. But really, at the moment, this code is only useful to you. So you have a problem. How do you get this code to your users? And this is really the fundamental problem of packaging. How do you get code to users? Maybe you talk to your friends, right? You say, hey, I have this totally awesome library. How do you send it to them? Maybe you could email it to someone every time you found someone that knew that wanted it at a conference or something like that, but that would pretty quickly become painful. Maybe you put it up on your personal website, somewhere with a link, and they can go and download it. And this is nice, because you could put like documentation there too, but how are people going to find it if they want it? So Python was first released in 1991. Google wouldn't exist for another 7 years. And so this leads us to a new problem. How do I find Python code? So what we need is a place where people can go to find interesting Python code, some sort of like index for Python packages. I think we'll call it, any ideas? The Vaults of Parnassus. So this is the Vaults of Parnassus. As you can tell, it's pretty old. So this was the very first index for Python software, and it was literally an index, which means that it just linked to something on other people's websites. And I hesitate to use the word package here, because at that point, what a package is really loosely defined, right? And the end result is that whatever those people felt like putting on their website is what you would get. So there's no standard, there's no enforcement of any quality level, et cetera, and this leads us to a new problem. How do I build this? So at the time, every project came with its own special snowflake little way to build it. So maybe it was a Python script, maybe it was a makefile, maybe it was just instructions in a plain text file. And this is really painful for users, right? Every time you want to go and install something, you have to figure out, all right, well, how do I make this so I can install it? The solution to this problem was a library called distutils. At the 1998 International Python Conference, which would become PyCon, a little project got started, and the name comes from distribution utilities. And this was included in the standard library in Python 1.6 in 2000. And this gave us kind of a familiar incantation, Python, setup.py, something. And I think a lot of people have actually run this without really thinking about what is going on here. This is just a Python script, right? There's a little bit of magic thanks to the standard library. And the original idea was, why write a domain-specific language or a new config file format when you already have the full power of Python at your disposal? We'll just write more Python. Why not? And we'll see why not in a second. And so it was really originally just a build tool to replace all those makefiles and Python scripts and stuff like that. And the goal was just to make something in a consistent way that could then be installed. Distutils also gave us a way to package up source code in a standard way for sharing. This is called a source distribution, and it's basically just a compressed archive like a zip file or a tar file, et cetera. This is also called an sdist. I like to say it like a snake, sdist. And you build it like this, Python setup.py sdist. So this might be a little familiar too. But pretty quickly it became obvious that sometimes source distributions weren't going to cut it. So there's a problem. Sometimes building things takes too long. Sometimes source distributions are fine, right? You just have a little bit of pure Python code and it's no problem. But sometimes they have so much to do during the build step, like possibly even compiling some C code, that it becomes really costly to do this every time that you want to install a dependency. And it feels really wasteful if you're doing it again and again and again for the same architecture on different machines. So the solution to this was something called built distributions. Instead of a source distribution, you take a distribution that has been pre-built for your architecture, and then you just drop it in place. There's no build step necessary, you just install. This is also called a bdist for built distribution. And you build it like this, Python setup.py bdist. So All right, distutils is pretty great. Gave us a consistent way to build things, which was pretty immensely helpful. But it punted on two key problems. The first problem is, how can I do packaging? And this is just sort of the generic idea of packaging. Like, how do you get the user to the state right before they want to run the build command? How do you get everything in place? Where they have everything they need, they've downloaded everything, but it's just not put together yet. So the original authors of distutils, they saw this as a solved problem. All the platforms that they ever imagined or envisioned anyone wanting to do Python on already had system-level package managers. I'm talking about Linux package managers like RPM. They couldn't imagine developers would ever want to do development on platforms that didn't have their own package managers. Guess what? Turns out developers love developing on platforms that don't have official package managers like macOS and Windows. So yeah, maybe your platform doesn't have packaging at all. There's also another problem with this. Maybe your platform does have packaging, like it's Linux, but you want things right now, right? So if your platform does have a package manager, usually releases to that package manager lag behind the author's original releases, because once the author has published code, the platform maintainers have to go take that package, do something magic to it, put it in that specific platform index. And as a user, you want that fresh release right now. You don't want to have to wait for some bug fix or security vulnerability fix or something like that. So the solution to this problem was the Python package index. This was to create an index that was just for Python. So authors could publish directly to it, and users could download directly from it. There's no delay in between, and it works across any platform. And we call this the Python package index. So this is what it looked like in October of 2002. And it was great. It gave us a really official, consistent, centralized place to put Python software. And I say put Python software because it still is linking to externally hosted files, but it's got a little bit more structure than the vaults of Parnassus. And we also call this PyPI. You can say it with me, PyPI, not PyPI. That's actually something totally different. And so again, naming things is really hard. And it's also called the Cheeseshop. And this is a reference to this Monty Python skit, where a man goes into a cheese shop, which has no cheese for sale. And the joke is that when PyPI was first created, there was no packages in it. So it does have a lot of stuff in it now, so it's not really probably appropriate to call it that anymore. So as soon as we have PyPI, we have a new problem. And this is the other thing that distutils punted on. And this is the ability to specify dependencies. So there's no way to say that for a given package, maybe on PyPI, that package depended on other packages being installed along with it. So this makes sense. Before PyPI existed, they didn't have a centralized repository to point to say this is where you find that, and this is where you find that. But now that we have this package index, it's possible to not only point to a version of a package somewhere, but it's also possible to ship more code to users than what they're getting with distutils in the standard library. So the solution to that problem was a new package tool called setuptools. And setuptools essentially monkey patch distutils in the standard library. And there's some advantages here, right? It made it possible to get code to users faster than distutils. You don't have to upgrade your entire Python distribution just to get new distribution utilities. But there are disadvantages too, right? Monkey patching is never really a very great idea, especially if you're monkey patching things in the standard library. But once we had setuptools, all sorts of nice things came along with it. So one problem that we had was that installing was just too hard. Maybe now that you have the ability to specify dependencies easier, maybe we want to make them a little bit easier to install as well. So setuptools came with another tool called Easy Install, and this allowed users to install dependencies for a project directly from PyPI, no problem. And this did, in theory, make it easier for users to install various projects, but it also introduced a new type of built distribution because the existing ones weren't cutting it. We call this the egg distribution. There were other types of eggs too, but the built distribution version is the kind of important one. An egg is just a zip file with some metadata, and it could contain Python bytecode at all. And this is, like I said, not a source distribution. It's built. It's all put together for your platform. And the name comes from Python. Pythons lay eggs. But Easy Install also gave us some new problems. Easy Install was really good at installing. It was so easy. It couldn't uninstall. It couldn't tell you what you had installed. And it also kind of messed around with sys.path, which is not very awesome. So the solution to that problem was a tool called PyInstall. And you've probably never heard of PyInstall, because as soon as it was created, we had a new problem. The name PyInstall is just too long. And having to type PyInstall, install, blah, blah, blah seems really redundant. So naming things is hard. And this was renamed to something probably more familiar, which is pip. That happens almost immediately. And pip is not, the name pip is not an obscure reference. It stands for pip installs packages. So we swapped the redundancy for a recursive backronym. Awesome, but it's much shorter. So yeah, easy install is still around at this point, but pip soon quickly becomes the preferred way to install Python packages. And pip does kind of an interesting thing. It ignores eggs entirely, and it only installs from source distributions. Basically, it saw a lot of problems with eggs, namely that it was really hard to specify what platform it was intended for, and it just said, we're going to ignore it entirely. So at this point, people are using pip to install dependencies for applications, not dependencies for other packages. So essentially, for an application, there is no top-level package to install where you can specify your dependencies. So if we want a way to specify dependencies for an application, what can we do? The solution to this problem is a file that pip introduced called requirements.txt. And this lets you list out all the requirements that you want to install in your environment and even pin them to specific versions. And this probably looks familiar too, pip install-r requirements.txt. And this allows for semi-reproducible environments. So this is great. And everyone is happily pip installing and going, wow, lots of things in the requirements.txt. And now we have a new problem. Installing from PyPI is getting kind of slow. So remember, at this point, PyPI is still just an index. So when pip has to install something, it has to go and crawl PyPI. And then it has to go and crawl a bunch of other domains that it doesn't have any control over. And those domains might not be very fast and performant. And for that matter, PyPI might not be fast and performant either. So this is a problem. The other thing here is you have to trust a third-party domain, right? As a package maintainer, my users have to say, yeah, I'm OK with installing this package from Joe Schmo's random website. What happens if I forget to re-register the domain my package is hosted on? An attacker can go and register it and put malicious code in its place. My users have no idea. They have become so accustomed to pip trying to connect to a bunch of random servers all over the place that they'll never even notice. So the solution to this problem was that PyPI begins hosting releases, literally hosting the code, the files for a package. And this is specified in a pep 438. And around this time, we start to notice a new problem. We need those built distributions again. Ignoring eggs was pretty good, got us around a couple problems. But there's still a lot of duplication happening when we're trying to install things from source, and it's taking a long time. So the solution to this is a new type of distribution called a wheel distribution. And this is just another built distribution. It's very similar to eggs. It's also just a zip file. But most importantly, it actually has a specification, which is PEP 427. And it was able to learn from all the mistakes of easy install and egg distribution. The name comes from a wheel of cheese. You put wheels in a cheese shop. I like to think that the author of the spec for wheel really got the name right, actually, on this one, because in addition, you can't say that you're going to rebuild the wheel. So it's here to stay. So at this point, a lot of people are really, truly depending on PyPI, and we start to get a little more focused on making sure that it's secure. So one problem that we notice is that when you run Python setup.py upload to upload your new package, it doesn't use HTTPS, which means that your PyPI credentials could be intercepted, or that you might not be talking to PyPI at all. The solution for this is a tool called Twine. In the same vein as setuptools and pip, this is a separate package from distutils. And all it's responsible for is securely uploading a new project to PyPI. And the name comes from tying up packages with Twine before sending them. And the name here doesn't really correlate super well, actually, what it does. Twine doesn't do anything to your package, as all the bundling has already been done. It just sort of looks up some information about it and knows how to send it to PyPI securely. And so it's kind of more like a package carrier, but yeah, naming things is really hard. New problem. PyPI is starting to show its age. So here is what PyPI looked like in 2007, and it was about 4 years old. here's PyPI about 2 months ago. I'll put those images side by side. It's kind of like one of those spot the difference games, right? So it's not really very fair to visually compare PyPI circa 2007 with PyPI in 2018. One thing that you can't you definitely can't see from these images is that in this amount of time, PyPI went from a place to put Python packages to the place to put Python packages. We went from about 3,000 packages to more than 130,000 packages. So this growth also included a whole lot of issues with PyPI being down or having outages and that kind of thing. And there were a lot of things, a lot of work that went on behind the scenes that didn't show up visually that allowed PyPI to continue to work. And the other thing is about PyPI, by its very nature, it predates almost all of the packages that exist on it right now. So that means that when it was created, all of the fancy, flashy web frameworks and testing frameworks and all that stuff, they didn't exist because there's no place to put them. So PyPI is, at this point, 15 years old. It has pretty much no tests. It has no modern web framework. And actually, even just to run it locally, you have to go and comment out a bunch of code. So what should we do, right? One thing we could do is we could rewrite PyPI from scratch. So normally, if you ask me if a full stack rewrite of a core piece of infrastructure depended on by hundreds of thousands of users would ever succeed, I would say, no way. But I don't know if anyone noticed, but this happened. This is our new PyPI. And this project is also called Warehouse. So Warehouse was exactly that, a full stack rewrite of PyPI. Warehouse, the name comes from a place to put packages. And this is a project that started more or less in 2011, and it had a number of goals. Basically, HTTPS everywhere, use modern best practices, web frameworks, tests, and it officially became PyPI in April of this year. And I have to say, this is a really tremendous undertaking, and it would absolutely not have been possible without significant financial support from the Mozilla Foundation. So thanks to Mozilla. All right, so that's it, right? We solved all the problems. We launched a new PyPI. Good job, everybody. No. We still have problems, but having problems is the very nature of software, right? Once we build the new and shiny thing, we start to realize what else it can do or what the need actually is. So one problem that we still have is that packaging is still kind of hard, especially if you're new to it all. There are a lot of different tools and things that you might have never even heard about until today. Solution to this problem that we're working on right now is something called Python Packaging Guide. And this lives at packaging.python.org, and it is a really carefully crafted and well-maintained guide to Python packaging. It has pretty much anything that you want to do with packaging is listed in there, and it's kept up to date. So check that out. Another way to do this is a project called Sample Project. So this is just a skeleton project for your Python packages, and it represents the kind of best practices for how to create a new Python package. So if you're thinking about publishing some code, go and check this out. Another solution to this problem is just kind of general care and maintenance. In general, I think these modern projects that I just was talking about, they're more well-specified, and they're also easier to maintain. And there's also a serious focus on making them accessible to newcomers. So they're not just tools for experts. And in fact, I would say that we actually have a new problem now, which is that packaging is maybe a little bit too easy. I could have called this talk, Python Packaging So Easy a Spammer Could Do It. So having packaging be hard actually has kind of some unintentional benefits, namely that folks that aren't truly invested in the ecosystem can't figure out how to use it. But unfortunately, this also excludes a lot of people who don't have malicious intent. So while lowering that barrier is a priority, it does produce new problems like spam on PyPI. There's also another problem that's kind of common these days. Sometimes you need more than Python. Sometimes you don't even have Python installed yet. Maybe you need like R, LLVM, HDF5, MKL, something like that. Maybe you don't even have Python on your system at all. So these are kind of things that are outside the scope of the Python Packaging Authority, which kind of just assumes that like A, you have Python, and B, you just want to do Python, maybe some C code as well. Solution to this problem is Conda. This is a tool that's not outside of the Python Packaging Authority, supported by the Anaconda company. And it's definitely, all those things are definitely within the scope of Conda, which is provided by that company. It's a Python agnostic packaging tool that's cross-platform. So you can install Python with it, you can install a lot of Python packages with it, you can install a lot of other stuff with it as well. And so it satisfies a lot of those use cases for people that need things more than just Python. Another problem that is happening right now is the ability to create a reproducible environment. So people finally kind of wisened up and said, oh, like, I want my production environment to be reproducible, for the same dependencies to be installed every time. So requirements.txt was a really great step towards creating that, but it only specifies sort of top-level dependencies, right? It doesn't specify the dependencies of dependencies and on and on. And so creating and maintaining that file can also be kind of challenging, right? Like, it's kind of a mix between a human editable file and a machine readable file. And maybe we have like multiple of these files, right? For deployment, for testing, for linting, whatever. So the solution to this problem is a new project called pip file, which produces two files, pip file, which is a single human editable file, and pipfile.lock, which is a single generated file with fully deterministic dependencies, which means that you'll always install the same projects every time. And this can be shared across multiple dependency installing tools, like maybe pip will support it someday. So if you come from another ecosystem, this actually might seem kind of familiar, because Ruby has this, it's gemfile.lock, the Node ecosystem has this, it's yarn.lock, et cetera, or package.json.lock or whatever. Another problem that exists right now is you can just do whatever you want in setup.py. And I think LVH was talking about this if you were at his talk earlier. Setup.py is just Python. You can do totally arbitrary things in it. And there's no way to truly predict what is going to happen. So this includes dependencies, right? Like, you can write a setup.py file that installs one dependency on weekdays and a different dependency on weekends. I don't know why you would do that, but you could. So I see questions about this, this like indeterminism of setup.py so often that I wrote a blog post about it. And the answer is like, yeah, you can do anything you want. And it makes it really hard to reason about source distributions. Like, people want to know, I want to see a dependency graph of all the packages that exist on PyPI. And it's like, it's actually not possible because we can't definitively say what one package depends on another. There's another additional problem with the setup.py file as well. Like I said before, this is sort of like relationship between distutils and setuptools. Distutils, again, is getting patched by setuptools, or monkey patched by setuptools. And extending and maintaining them is difficult. Distutils, because it's in the core Python library, so you have to be a core developer to change it. And setuptools, because it's like really old and kind of a big ball of monkey patch and mud. So while there do exist various solutions to these problems, they're kind of hard to implement, and they're even harder to maintain with the existing tool set. It's also really difficult to use anything other than distutils and setuptools because they are essentially the de facto standard. So it kind of becomes like a chicken and egg trying to change it. There's a solution, though. The solution is two new specifications, PEP 517 and 518. 517 is a build system independent format for source trees, and 518 is the ability to specify minimum build system requirements for Python projects. So what this means is that it is now possible with a new file called pyproject.toml to step away from distutils and setuptools just entirely. And you can allow users to specify their own build requirements for their project. So if you need X and Y installed just to build your project, you can specify that, which wasn't possible before. And those will be installed prior to building, and they'll be available when you go to build your project. So they could be setup tools, could be something else entirely. I don't think there's anything else to replace it quite yet, but someday there might be. OK, that was a lot. So a lot of problems, and you might be like, oh, you guys have a lot of problems. How can I help you? Cool. Yeah, also consider, unlike Anaconda and Conda, unlike npmjs.com, and with only a very few small exceptions, Python packaging is an entirely volunteer-driven project. So yeah, maybe you would like to help. So both PyPI and pip have a really great and well-maintained issue tracker, and they have a good first issues label in the tracker. So if you wanted to become a contributor today, you can go and do this. And you can definitely go and do this with PyPI today because happening right now is EuroPython development sprints, and they are going crazy on our issue tracker right now. So yeah, go and find some good first issues. You can work on that. Also, I think Ernest and I are going to try and put together a little packaging BOF tomorrow. I'm not sure what time yet, but if you're interested in asking questions about packaging or have some ideas you want to share with us, or you just want to like get set up with running PyPI on your machine locally, which is totally possible and awesome, yeah, come to that and we can help you get set up with that. So I told you how you can help us. Here's how we can help you. If you're having problems, you can do the following, sort of in the order for how quickly you need the problem solved, from very quick to it might take a while. So the first is, like I said, you can go to the Python packaging guide at packaging.python.org. The second thing you can do is you can go to the issue tracker for the tool that you're currently trying to interact with. So if that's pip, you go to PyPI/pip on GitHub. Issue tracker there is, all the issue trackers for these tools are monitored and responsive and that kind of thing. You can also hop on IRC. I know a lot of people don't use IRC anymore, but we still do. There's a PyPA channel. You can come and just talk to folks in the organization. And lastly, there is a kind of generic GitHub issue tracker called Packaging Problems. And this is kind of for like big ecosystem-wide problems, something that you're not going to expect to get fixed anytime, like not tomorrow, but maybe someday we should start thinking about trying to solve this problem that you're having, and we can discuss it there. All right, so to summarize, packaging isn't bad, but there are always going to be problems to be solved, right? We've made really gradual changes over a really long period of time, and each change has been a response to an evolving need. So comparatively, it used to be really bad, and we might have just forgotten how hard it used to be. So the next time that you're frustrated with Python or packaging, go and imagine a world with no pip and no PyPI, and think about making a pull request or something. Thanks, everyone. So I think we have a little bit of time. I'm happy to answer questions. We can also hang out afterwards. Totally up to you. Sure. So it's sample project. The URL is PyPA/sample project.